Arc takes a totally new approach to Bitcoin scaling, so it can be tough learning about all the new concepts for the first time. I figured that the best way of describing how the Arc protocol works would be to walk through the life cycle of some sats traveling through the protocol and explain each new concept as we go. What I mean by the life cycle in Arc is getting Bitcoin onto Arc, sending some sats to a friend over Arc, refreshing the sats that they received, and getting your remaining sats off Arc and back on chain. Of course, the vast majority of Arc users will not be needing to board and offboard for every transaction, but we need to make sure that we include them so you understand how Arc works. Okay, let's get started. Before getting to boarding, let's briefly take a look at the structure of Arc so that you've got the lay of the land. Because Arc is Bitcoin scaling tech, people are immediately going to start drawing comparisons with the Lightning Network. But Arc looks completely different from Lightning. Lightning was built to be purely peer-to-peer, with each user running their own node, and they connect that node to multiple other nodes, and then most of their payments are expected to travel through multiple channels to get to the destination. Arc takes a different approach. It uses a client-server model where users connect their wallets to an Arc server and transact with other users of that same server while still keeping custody of their Bitcoin. Once connected, you can make fast payments at low cost, and any sats you receive are self-custodial. Onboarding is fast and easy, there's no need to open any channels or manage liquidity, and Arc can even make sending Lightning transactions easier. The Arc protocol is totally open source, so anybody can run an Arc server, but there's definitely network effects at play that make it likely that users will gravitate to a few big ones. It's important to highlight that you can't send payments to users on other Arcs, at least you can't do that natively. You'd need to use Lightning as a kind of interoperability layer between the Arcs. To understand how Arc works, let's start at the beginning. How to get on-chain Bitcoin off-chain onto Arc. This process is called boarding. To board an Arc, you connect your Arc wallet to an Arc server, then work with the server to construct and pre-sign a pair of transactions. These transactions have some fancy spending conditions that combine multi-sig and time locks to create a kind of pseudo-covenant. You broadcast the first transaction on-chain, that gets your sats onto Arc. But you don't broadcast the second transaction, which sends the sats to a wallet you control. You keep hold of it off-chain, and you only use it in an emergency. More on that later. Together, these transactions represent a virtual UTXO, which we call a VTXO. We don't have time today to get into the nitty-gritty of how a VTXO works, but let's cover what they achieve. You can get your sats back on-chain using the reveal transaction at any time, but only after a delay. The delay is important for spending your sats on Arc. We'll get into that next. Your sats can be spent anywhere if you and the Arc server both approve. After a certain period of time, the Arc server can also spend your sats without your approval. We call this the expiry. We're expecting it to be 30 days, but each Arc might use a different time. Most users won't actually need to go through boarding. They'll just receive their Bitcoin over Arc directly from somebody else that has. That's the magic of Arc. New users can get started transacting off-chain as fast as it takes to download a wallet app. So we've covered getting onto the Arc protocol. Now what happens when you want to send some sats to a friend? In some ways, spending sats on Arc looks a lot like spending on chain. You get a Bitcoin style address from your friend, sign the transaction, spend a whole output, and send any excess sats back to a new address in a wallet as change. But under the hood, it's slightly different. Again, signing a transaction is an interactive process between you and the Arc server, where you create a new set of exit transactions, a new VTXO for your friend. Like the boarding transaction, your friend can broadcast the transactions at any time to get their sats back on-chain. Your friend can also spend the transaction to any address with the approval of the Arc server. But unlike the boarding transaction, neither of the transactions are broadcast on-chain. They're both kept off-chain only. You and the Arc server co-sign the transaction. This means that the payment is secure as long as you and the Arc server don't collude to double spend. The expiry time of the new VTXO does not restart. It's inherited from the VTXO it was spent from. So if the original VTXO had 10 days left, that's how long the new VTXO will have left too. So we mentioned a time lock delay on the exit transaction earlier. That's necessary because it provides a window for your friend to broadcast their exit VTXO if you ever attempted an exit. Their transaction will always take priority. Your friend needs to trust that the payment that they received is not double spent by you and the Arc server colluding. It's a pretty good assurance. Your friend trusts you already, and any Arc server caught colluding to double spend will be quickly discovered and go out of business. As long as at least one of the two is acting honestly, your friend is all good. But let's say it's a large payment and your friend wants to make the received payment even more secure. To do that, they're going to need to refresh the VTXO. Refreshing is where the real magic of Arc happens. It's what enables Bitcoin users to maintain Bitcoin balances totally off-chain while still having verifiable proof that they can retrieve their balances on-chain without any input from third parties. The refresh process is another interactive process, but this time, your friend is not pre-signing transactions with just the Arc server. They're signing together with any other users that are refreshing transactions at the same time. The details of the refresh process would need a whole video on its own, but to give you a basic understanding of how it works, together with the Arc and other users, your friend constructs a transaction tree that contains new VTXOs for all the users involved. At the same time, your friend forfeits the VTXO they received from you. A forfeit is like a payment back to the server, but with an additional condition that it's only valid if the server gives you a new VTXO in return. The transaction tree is similar to the boarding VTXO, except that instead of one UTXO and one pre-signed exit transaction, it's one UTXO and many pre-signed exit transactions. Everything required to get everyone involved their Bitcoin back on-chain in an emergency. This is a highly interactive process with your friend pre-signing every transaction related to their branch on the transaction tree. Your friend then stores the pre-signed transactions locally in case they're ever needed. And the Arc server embeds the transaction tree in one UTXO and broadcasts it on-chain. The result is one large on-chain UTXO equal to the total amount of Bitcoin involved in all of the refreshes, providing your friend on-chain assurance that they can retrieve their Arc balance at any time and without having to trust any third parties. And what I mean by that is they don't need to trust either you or the Arc server anymore. So if you've been keeping up with the explanation so far, you've probably noticed that this refresh process can't just happen at any time. If it did, it would be almost impossible to get enough users to regularly turn up at the right place at the right time. So the solution is to process refreshes in periodic rounds. We're expecting rounds to occur every hour, but round frequency is another parameter that will be defined by each individual Arc server. So, after receiving their payment, your friend just needs to make sure that their wallet is online when the next round starts. Then their wallet software will coordinate the refresh. After the refresh is complete, your friend's Arc balance is now totally secure and the expiry deadline is reset. If the Arc has a round interval of 1 hour, then the longest that they'll need to wait between receiving a payment and refreshing is about 1 hour. And eventually, any VTXO is going to need to be refreshed to avoid it expiring. The question for any user is just how long to push it before refreshing. It'll be affected by liquidity costs, and we'll go into that next. A question that you're less likely to have noticed is, where does the Bitcoin from the round transaction actually come from? So this is where the expiry and liquidity come into play. Your friend forfeit the VTXO as part of the refresh. But let's say their VTXO won't expire for another 10 days. The Arc server will need to wait that long before it can access the sats. That means at the time of the refresh, the round transaction must be funded with Bitcoin from the Arc server's own wallet. The Bitcoin in that wallet will be a mix of forfeited Bitcoin from the users and Bitcoin provided by the Arc server. Maintaining sufficient Bitcoin to cover each round's refreshes has a cost of capital associated with it, which we call the liquidity costs. You sending the transaction to your friend was extremely cheap. The Arc server only needed to co-sign the VTXO off-chain. But your friend refreshing their VTXO is less cheap because the Arc server needs to cover the on-chain transaction fee for the round transaction, plus the cost of providing the liquidity for 10 days. A dynamic that emerges from this is that the closer to expiry your friend waits to refresh the VTXO, the cheaper it is to refresh. For example, if they wait till an hour before expiry, then the Arc server would only need to cover an hour of liquidity. But as we mentioned before, it's important that your friend refreshes the VTXO before it expires. Otherwise, the Arc server can technically send the sats anywhere it wants, and you'll need to trust that they'll refresh on your behalf. While there's a lot of incentives for an Arc to behave honestly, the point of Bitcoin is to minimize trust. So it's best to make sure you always have the option of a unilateral exit and you refresh in time. So I haven't mentioned Arc's fee structure at all yet, and honestly, the reason for that is we're still working out what's best for users. For now, just expect that all transactions will require a fee, but don't worry, it'll be significantly cheaper than transacting on-chain. And if all this sounds super complicated and something that you wouldn't want to deal with, don't worry. It will all be handled by the Arc Wallet software automatically. Your friend won't have to worry about manually refreshing. They'll just set their preferences in their app settings, and then their wallet will take care of the rest. All they have to do is make sure that their wallet goes online regularly. If you're finding this video helpful, please stop what you're doing now and hit that like button. We want to make sure more people are learning about the Arc protocol. Next, let's imagine you've made a few transactions on Arc and you want to bring some of those off-chain sats back to your on-chain wallet. This is called offboarding. Similar to refreshing, you need to wait for a round, connect to the Arc server, and forfeit some VTXOs. But instead of creating some new VTXOs, the Arc server adds an additional output to the round transaction, sending on-chain sats to your on-chain wallet. Once the round transaction is broadcast and confirmed, you've successfully offboarded. Like all interactions on Arc, this is completed atomically, so you don't need to trust that the Arc server will deliver the on-chain Bitcoin. And like with refreshing, there will be on-chain transaction fees plus liquidity costs that you need to cover. The closer to expiry your VTXOs, the cheaper the offboarding will be. But what if the Arc server is not cooperating with your offboard? Maybe they're experiencing some downtime, or maybe they've gone completely rogue. While this should be very rare, and ideally it never happens ever, the Arc protocol is built to ensure that you can always regain control of your Bitcoin on-chain. In the event of an emergency, where you absolutely cannot offboard for whatever reason, then you always have the option of performing a unilateral exit. This is where all those pre-signed transactions come into play. To exit, you broadcast the transactions in order until you deliver the sats to an address that only you have control over. Keeping with the tree analogy, you first broadcast the root, which breaks up the round UTXO, then each transaction in your branch, before finally broadcasting the final transaction called the leaf. That gets your sats from the Arc onto an address only you control. You might have noticed that there's some Bitcoin from other users included in these exit transactions. This is sent back to the transaction tree, breaking the round UTXO into multiple UTXOs. Other users on the Arc then have the option to use their pre-signed transactions to perform exits if they need. You need to be aware that there's a cost to unilateral exits to prepare for, so each of the exit transactions from the root to the leaf will need to pay an on-chain transaction fee. That means if you're storing a very small balance on Arc, it might not be economical to complete a unilateral exit. But there is a dynamic where if someone performs a unilateral exit before you, you can reduce the cost of your exit. This is because they've unwound your branch of the transaction tree, reducing the number of transactions you need to complete to get to your leaf. At the end of the day, this unilateral exit feature is what makes Arc special. You can transact fast and cheap off-chain while still having the confidence that you ultimately have control over your Bitcoin. To recap what we just covered, you boarded the Arc by sending Bitcoin to an Arc address and received a VTXO in return. The VTXO is a series of pre-signed transactions that you hold off-chain in case you ever need to do a unilateral exit. You sent sats to your friend by chaining a new VTXO from your old one and co-signing with the Arc. The received VTXO requires that your friend trusted you and the Arc server not to work together to screw him with a double spend. Your friend prioritized security over fees, so he refreshed in the round immediately following the received transaction. And in the refresh, your friend forfeited their VTXO and gained a new one, and this time the VTXO was included in the transaction tree that's embedded in the Bitcoin blockchain. The Arc server provided the liquidity for the round transaction, and they'll retrieve the same amount of Bitcoin once the round's VTXOs expire in 10 days. After the refresh, your friend didn't need to trust either you or the Arc server anymore. He can retrieve his sats on-chain even if the Arc server is offline. You then offboarded your remaining sats, where you waited for the next round, then coordinated with the Arc server to forfeit your VTXO, and at the same time, the Arc server added a new output to the round transaction, delivering the sats to an on-chain address you control. And given that the Arc server cooperated, you didn't feel the need to do an exit, but you felt a lot better using Arc knowing that it was always an option. Okay, I think that's a wrap for our overview of the Arc protocol. If there's something I missed or something that's unclear, please let us know in the comments. We'll do our best to get back to everything down there. This video is a new format for us, so any feedback will be super helpful for improving future videos too. And of course, don't forget to like and subscribe. Thanks for listening, and catch you later.